So when we're dealing with the complement of a set, we first start with the universal. The universal set, U, is the set of all elements we are considering. For example, if we're considering just the digits, numbers that make up the numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is our universal set. Then from the universal set, we can define subsets. Composite numbers are numbers that have factors other than 1 in itself. Prime only has factors of 1 in itself. Okay. All right. Prime numbers, we always start with 2. We never go lower than 2. 2 is the smallest prime number. Now the complement is the set of all elements of U that are not of A. And we mark that A prime. For example, say that these are my universal numbers. Each time we set up our universal is something different, or sometimes it's the same, it doesn't matter. Just make sure you understand what the universal set of numbers are for this problem. Out of these numbers, if A is made up of 1, 3, 5, 7, and 8, A prime are the numbers not in A. 2, 4, 6. So we can make 3 immediate observations about complementary sets. If we intersect A and A prime, it's the null set because they have nothing in common. If we union A and A prime, we get the universal set. And back to this one, if we combine A and A prime together, that's what makes the universal set. Then if we have the number in A plus the number in A prime, we should have the number in the universal set. And this section is really just getting familiar with the terminology universal and complement, and reminding what the null set where it's empty, and the intersection, the union, and the number in the set. All right, letter D is all about specific number sets. So I always draw a nice big box here. All right, and we talk about the most basic set of numbers, and we call those the natural numbers. I go back to college when we used to put a line through it. The natural numbers are the numbers you start with 0, and then the numbers you count by. 0, 1, 2, 3, 4. Okay. Then what do we need to add? So sometimes it helps to think of like a number line. If I have a number line, we started with 0, 1, 2, 3, and we're going this way. What numbers do we need to add in next? Next, we're going to add the integers. Z is the integers. So all of the 0, 1, 2, 3 numbers are in here. So in this circle are just negative numbers because Z includes everything that's a natural number. But now I'm adding in the negatives. All right. So if right now it's just the numbers that are on, it's the whole numbers and their opposites. What do we add in next? We need to add all in the decimals. I'm going to draw a little line here. We're going to call this Q for rational. Q, what math word do you most connect with Q? Quotient, right? And what's a quotient but a fraction? So when we add in fractions, decimals, they can be positive or negative. They're on the outside of this circle. So first of all, everything in this box could be written as a quotient, even your whole numbers, because like 1 over 1 still can be written as a quotient. So if it falls inside this circle, it's only a natural number. But if it falls in the Z circle, it's both an integer and a natural number. The other thing that they'll sometimes do is they'll go like this. These are the positive integers. All right, so that's notation that's helpful to understand. Now, the only others, we're still missing a few numbers that cannot be written as a quotient. If these are rational numbers, what do we have next? Is the irrational numbers. So what numbers are irrational? Pi, 3.14, blah, 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 blah. Square root of 2, square root of 3. Now, square root of 4 is rational because the square root of 4 actually is 2. Okay? So getting to know your symbols, N is natural, Z is an integer, Q is rational, and R is real. And those are all the different symbols you've got to know, just because that's how they'll identify the different sets.